Now over here, I'm using a pipe stand. Of course, your piping may be piped to an actual component out in the field, such as a condenser, an evaporator, a liquid line, or whatever. But the same sequence of events need to occur no matter what you're doing. The only thing that might be slightly different is if you're brazing vertically, but on this one we're going to do horizontal. We may do a vertical braze in the near future on another video. Okay, like I said before, once we've set our pressures to where we want them, we're ready to actually begin the brazing operations. Now before you do that, you want to change over your clear safety glasses to the appropriate lens, and I happen to have them on already. And you want to put on safety gloves. Of course, we're supposed to wear the appropriate safety glove no matter what we do in the field, so to protect our hands. Now I'm going to take the torch in my hand, and I'm going to face the tip away from anything that's possible flammable, myself included, and someone beside me. I know you guys come out here in the gas shop and you've got someone that's in 2 feet away from you, brazing right beside you, so you've got to be careful where you place this heat. So I'm going to take the appropriate mechanical striker to strike to ignite this fuel gas, and you never want to use any type of lighter to do that due to the safety hazard of it blowing up in your face. Now when you get ready to strike this, what you want to do is you want to add the fuel gas. You want to open the fuel gas and crack the fuel gas just slightly, just enough to strike. And notice how I've got it away from my body, and immediately strike the fuel gas and ignite it. Okay? I'm going to add the fuel gas to about the amount, and you'll get a feel for this when you get out in the field, to about the amount I think that I'm going to need to do my brazing operation. And then I'm going to add the oxygen to get a good neutral flame. Now this tip is not the best tip. You can get a much sharper flame than this. This one actually has probably been reamed out a little bit too much. I'm going to add a little bit more fuel gas, a little more oxygen to get it where I want it, and get a good neutral flame like this right here. Okay? Now taking your torch and your brazing alloy. Now this brazing alloy, you always want to make sure that you clean your pipe utilizing a sand cloth, or you can use some of these Scotch-Brite pads, anything that'll clean the pipe. You always want to clean your pipe, and you always want to ream your pipe, because it can cause turbulences in the pipe, which is something that we don't want except for in certain areas. Now we don't have to apply flux, that's optional when using the B-Cup series alloy, because the B-Cup series alloy has phosphorus in it, like I said before, which does somewhat the fluxing for you, if you will. Now, when I start this brazing process, I always want to preheat the tube itself, not the fitting. Okay? You want to preheat that tube and get it good and hot, because once you go to the coupling, that's when you're going to start applying your metal. You want to preheat the tube and get it to the appropriate temperature, and then you want to go to the coupling. And you want to start, when you're adding your filler metal, you want to start at the bottom at around 7 o'clock and work your way up to the top, and then start back down at the bottom again on the opposite side, overlapping where you began, and come back up to the top, overlapping once again. You want to move your torch back and forth so as not to burn a hole in the pipe and not to overheat the pipe, which could deform the pipe. Okay, now I'm getting the pipe good and red before I begin this process. Once again, this alloy takes at minimal 1200, 1250 degrees, and some upwards of 1400 degrees before it starts to melt and join the surfaces together. Now, once I get this good and hot, I want to take this heat and I want to take it all the way to the back, the stop of the coupling, which is in the center. The stop is where you shove the pipe in, and it stops the pipe from going inside the coupling. So you want to make sure you push it all the way in, and then you're going to pull your heat back past the stop of the coupling, because the filler metal is going to run to where the heat is being applied, and it's going to stop where the heat stops. So I'm going to drop down on one knee now that I have the inner tube good and hot. I'm going to drop down where I can see what I'm doing. I've just about got the inner pipe good and hot, and I'm going to start down here at the bottom, and I'm going to take my flame back past the stop of the coupling and move back and forth to have even heat. And then I want to apply my filler alloy and pull it up to the stop of the coupling. Always keeping the heat back past the stop of the coupling. And I'm going to work my way up, massaging this and keeping the pipe good and hot and tilting my flame towards the pipe where both of them are staying hot, and I'm going to work my way all the way up the fitting. I've made it all the way up to about 3 o'clock now. I'm going to push that filler metal in because I want it to go all the way up to the stop of the coupling, bringing it all the way in. And if you get it hot enough, you can physically see the filler metal go all the way up to the stop of the coupling. I'm going to concentrate my heat to make sure it evenly goes into the stop of that coupling. Alright, I've got it all the way up to the top, and I'm pulling that alloy up to the stop of the coupling. Now I'm going to go back to the other side and start back off where I started from before and work back up the other side. I'm going to get it back hot again, good and red, because it helps this alloy to flow evenly. And you also don't want to have one heated more than the other. If you have one heated more than the other, what's going to occur is it's going to run towards where more heat is applied. So your filler metal will run towards the hotter surface. You want to have them good and evenly heated. And I'm going to work my way all the way back up to the top, pulling that filler metal all the way in. Overlapping at the top. Knocking off any excess debris on the bottom. And the joint is finished. And I'm going to extinguish my flame by shutting the oxygen off first and the gas off last. And once you've finished all of your brazing process, you want to come over and close both of your tanks, your valves on your oxygen tank or oxygen cylinder all the way. You want to close your acetylene cylinder as well. You want to back off your adjusting screw because it is what determines what amount of pressure is being applied to your torch. You want to back it all the way out, which shuts it off. Make sure you don't back it too terribly far. You can actually feel the adjusting screw being loose where it's threaded in. You want to back this one out as well on the oxygen. And I can feel it loose, and I'll run it back in just slightly. And I'm going to purge any excess oxygen or fuel gas that's in my hose. Purge all of it out. Then I'm going to close it back. And that is the end of the process. Guys, a few other things I wanted to talk to you about during this process. Once again, for time reasons, we went ahead and had this rig prepared for the brazing operation. But I want to make sure that you understand, sometimes the tips inside these torches get fouled. They have a tip number on them as well, and you can look at your tip chart and see what size pipe is recommended, what the CFH is that these tips use. That's cubic feet of gas that they burn an hour when they're under full load. You never want to use too large of a tip that you have to turn the gas down so much that you end up damaging the tip. You've got to be able to load the tip up. But these are tip cleaners that you can use anytime these tips get fouled. You don't want to use any kind of foreign object. You always want to use an approved tip cleaner, and they come in something that looks like this, readily available at all the parts houses. They also make a drill bit looking tip cleaner that is designed for cleaning these things. Second off, if you're ever brazing out in the field in an area where you are having to repair a leak or make a joint near something that is very heat sensitive, something that cannot be heated to an extent where it'll damage it, there is several things that you can do. You can use this heat absorbing paste, which is a heat sink, and they also have other types of heat sinks that come in a container like this, and they also have it in a spray bottle that you can spray it on. Also, a wet rag works very well, as long as you make sure that that rag is good and wet. You don't want it dripping though. A lot of times that'll actually hinder the brazing process and extinguish your flame. Once again, look back at the tip chart for what size is recommended. You can look at the tip chart and get an idea of what size you need, and also what size heating rig that you need. This is capable of doing a lot of joints in an area where you're going to be doing a lot of piping. Or we have what I refer to as a mini rig that us as technicians, the mechanical service technicians, and plumber and pipe fitters as well, when they're doing smaller jobs, we use this mini rig as well. Now you can leak check it just like you do on the larger heating system, and it's a lot more user friendly, and you can carry it on your truck. So I just wanted to go over those few things with you. Like I said, if you've got any questions, just give me a call here at the MTI JTT. Thank you for your time, and look forward to doing another video with you and answering any questions that you got. Thanks.